Okay, good morning. We are spending another day on perimeter and area. So just to review from yesterday, ladies, just to review from yesterday, what is perimeter? Adding all the edges up. Adding all the edges up is perimeter. And area is how many squares fill the shape. How many little squares, and that's why when we have area, our units are always units squared, because they're little squares that we're filling the shape with. We had some formulas. What was the formula for the area of a rectangle? Area equals base times height. What's the formula for the area of a parallelogram? Base times height. Okay. What's the formula for the area of a triangle? Half base times height. Very good. And then, of course, we also had the area of a trapezoid, which was a little more complicated, but it was half the height times the sum of the bases. It has a bottom and a top base, and those are the edges that are parallel. Maybe we should add a picture in, actually, now that I think about that. So here's like a little trapezoid. It's important we know that the two sides that are parallel represent the base 1 and base 2. And of course, the most important feature we talked about yesterday was a height. And the height always had to be a perpendicular height. And so you needed to look for this little box to find that perpendicular height. And that even sort of looks like an H, right? You got the line with the little box on the end. It's like an H, okay? So super important that you find that perpendicular height. Okay, so today we're sort of using those same formulas. We want to be able to go backwards and do some applications as well. So number 19, we want to find the base of a parallelogram. So here we have a parallelogram with a height of 10.5 feet and an area of 189 square feet. So first of all, they tell me that I have a parallelogram. What's the formula for the area of a parallelogram? Yeah, it's just base times height. And in this, what can we plug in with the information that they gave us? Like, where can I put the 10.5? Oh, we could put it like here in my picture. I could put the 10.5 as the height. But what about in the formula? Can I put it somewhere in the formula? Yeah, it says the height is 10.5, so we're going to put that in place of H. And it says it has an area of 189, so where can I put the 189? In place of A, very good. So we're going to plug in and solve. So we're going to have 189 equals the base times 10.5. So how do I get B by itself? Divide. I want to get rid of that 10.5, so we're going to divide both sides by 10.5. So those cancel out on the right. And can you use your calculators? Because I don't have one. 189 divided by 10.5 is 18. All right, so the base is 18, and it must be 18 feet because we were using feet for our units. So 18 feet. So we're now going to be using our formulas and plugging in and helping us solve. All right, so see, a triangle has an area. So right here on number 20, the first thing I'm going to write down is my formula for the area of a triangle. So what is the formula for the area of a triangle? Half base times height. Very good. Half base times height. All right. It says a triangle has an area of 220 square meters. So where do we put the 220 in? A, yeah, it's 220 square meters. That's area. So we can pop that in right there for A. And it says find its height if its base measures 20 meters. So where should we put the 20? B, yeah, it's the base value, so that goes in place of the B. So let's plug in what we know. We know the area was 220 meters squared, and then we have 1/2 times, our base was 20 times the height. So I'm going to do a little bit of cleanup. What is half of 20? 10. So I have 220 equals 10H. And how do we get H by itself? Divide by 10. Yeah, absolutely. So we get H equals, hey, the zeros just cross out, and I get 22. And I guess we're talking meters, 22 meters. So using the formulas to go backwards, 21 and 22 are the hardest. Because it's a trapezoid has an area. All right, what's the formula for the area of a trapezoid? Half height times base 1 plus base 2. Very good. 1/2 the height times the sum of base 1 plus base 2. Okay, it says the trapezoid has an area of 27.5, so the area is 27.5 centimeters squared. Where do we put the 27.5? In place of the area. Very good. What is the measure of the height if the bases measure 7 and 4? Where should we put the 7 and 4 in? B1 and B2, very good. So base 1 and base 2. So I'm going to plug in what we know. So 27.5 equals 1/2 times H times base 1 was 7, base 2 was 4. So I'm just plugging in what we know, and that's going to leave H, and that's what they wanted us to find. It said, what is the measure of the height? So that's what we want to find, H. So again, I want to do some cleanup. Clean this up a little bit. Inside parentheses, I need to clean up the parentheses first. PEMDAS. I have 1/2 times H. What is 7 plus 4? 11. Good. All right. And then, all these three things, the 1/2 and the H and the 11, they're all multiplied. All right. And multiplication is commutative. I can trade places, right? I can rearrange. 5 times 4 is the same as 4 times 5, right? Okay. So what I'm going to do is I'm going to simply do a little rearranging so I can multiply my 1/2 times 11. What's 1/2 of 11? Almost. 5.5, yep. So 27.5 equals 5.5 times the height. Yeah, 1/2 of 11 is like 10 divided by 2, so that's 5.5. All right, how do we get H by itself? Divide by 5.5. So the 5.5s go away, and we get H equals, I need some calculator help. Oh, just 5. Cool, and that must be centimeters that we're talking about there. 5 centimeters. Okay, 22. Find the length of the second base of a trapezoid that has an area. So again, we want the formula for a trapezoid. What's the formula for the area of a trapezoid? 1/2 height times base 1 plus base 2. Again, these are good formulas to memorize. And again, we want to plug in what we know. It says one base, it measures 8 inches, so I get to put 8 in there for one of them. It has a height of 13, so that goes in place of the height. And it has an area of 149.5. Where do we put the 149.5? In place of A. Very good. Lennox, are you with us? Yeah. Right? Thanks. All right, so I'm plugging those things in. We got 149.5 equals 1/2 times my height of 13 times the base of 8 and I don't know what the second base is, and that's good because that's what they wanted me to find. Find the length of the second base. So again, I'm going to clean this up a little bit. I can take half of 13. What is half of 13? 6.5, yeah. So 149.5 equals 6.5 times 8 plus b squared. So a little bit of cleanup there. Then what do you guys want to do next? There's a couple options that we could do. Yeah, we could absolutely divide away the 6.5 if you want to. Do you want to go that route? Yeah, we could divide. Well, so when we divide, the nice thing is 6.5, it just cancels out. We don't divide because this is multiplied. It just cancels itself out, just like it's been doing over here, which is kind of nice. We could also distribute if you wanted to, and eventually you'd still have to divide by 6.5. Okay, but this actually saves yourself a step. What in your calculator? 149.5 divided by 6.5, please? 23 equals 8 plus b sub 2. And then how do you get b sub 2 by itself? Not divide. Imagine the sub 2 wasn't there. That's confusing. How do you get b by itself? How do we get rid of the 8? Subtract. Oh, yeah. Okay. Yeah. So, yeah, just subtract. Good. 23 minus 8 is 15. So 15 equals our other base. Yeah, you don't have to take a square root or anything. Nothing complicated. The sub 2 is different than the power of 2. I love that you said that, though, because it didn't occur to me that that would be confusing for you. But, yeah, I get it. Totally. Okay? Questions so far? Okay, good. We just have a couple more. So application problems, very good here. Draw pictures when necessary. It's always a good idea if you need to draw a picture. So let's go ahead and read. A 7-foot by 3-foot doorway is to be cut in a trapezoid-shaped wall as shown below. So this is the doorway that they're going to cut, and it's 7 by 3 feet. So that's the doorway that's going to be cut out. Find the area of the wall with the door cut out. Interesting. We want the area once we remove the door. What should we do first, do you think? Yeah, let's figure out the whole area. So we want the area of, what shape is this? Trapezoid. What formula am I going to use? Times base 1 plus base 2. Beautiful. 1/2 height times base 1 plus base 2. Now, Seamus, when you ask me how do I do this, I'm going to say, I don't know, because you're not writing it down right now. So let's write these down. Thank you. All right. Let's see here. What can we plug in? We want to figure out the area. We have 1/2. What's the height of our trapezoid here? 16 is the height. We can assume that this is a wall and most corners are right angles. Well, if your house is new anyway. There's your height. And then what are my two bases? Yeah, these are my parallel top and bottom. So those are my bases. So 28 plus 13. Would you plug that into your calculator for me? Figure out what the area of our big old trapezoidal wall is. You got 328. Can I get a second on that? Who else got 328? Anybody else? Yeah? Okay, great. Thank you. Okay, so the area of this whole thing, what else do we need to do if, subtract what? 21. How'd you get 21? Oh, because you found the area of the door? All right, so the area of the door is 7 times 3, which is 21 square feet. And so what we want to do is subtract away. We're removing the door, right? And so to figure that out, then I just need to do the 328 square feet minus the 21 square feet, and we get 307 square feet. So the area of the trapezoid minus the door, because we're taking away the door. All right, any questions on that one? All right. Mr. Brinkley has a triangular-shaped area for his horses, measuring, so it's triangle. Maybe I'll just draw a sort of triangle. Okay, there we go. Triangular-shaped area for his horses with sides measuring 30 meters, 30 meters, 64 meters, and 87 meters. He would like to enclose his area with a fence. If the fencing comes in 2.5 meter sections, how many sections of fence will he need? What do we need to know first? The perimeter, very good. The perimeter of his triangular yard is going to be what? All of them added up. So 30 plus 64 plus 87. Plug that in for me. What do you get?
91.
181. Can I get another 181 in there? Yeah? Okay. So this is 181 meters of fencing to go all around. But they only come in 2.5 meter sections. Those are like those pre-built fence walls like you can get at like Home Depot or whatever, the pre-built walls. So how do we figure out how many of those pre-built walls we're going to need? Yeah. So the 181 meters divided by the 2.5 meters, what is 181 divided by 2.5? 72.4 sections. The meters cancel out, so now we're talking about sections of wall. So can we buy 0.4 of a section of wall? No. Okay. So that must be 73 sections, because of course we can't really take just a portion. They wouldn't appreciate that. Right? I just want 0.4 of your wall, not the whole thing. Okay. Questions so far? Okay. Let's just do 4, and then we'll call it good. Mrs. Humphrey needs to replace a broken window in her house. The window is shaped like a trapezoid. So here's the shape of her window, which is very good, with dimensions shown below. If glass costs $21.50 per square foot, how much will the replacement window cost? Per square foot. If it's square feet, do you think we need perimeter or area? Area, okay. Paying attention to the units can be super helpful. So because I know that we're talking about $21.50 per square foot, I need to know the square feet of the window. So I want the area of our trapezoid here, which I know is 1/2 times height times base 1 plus base 2. So I'm going to plug in. My height is 1.5. And my base 1 is 6, and my base 2 is 2. Will you go ahead and plug that in? What do you get? 6? Okay, and that's 6. We're talking square feet. All right. So again, if glass costs, so 1 square foot is $21.50. What's 2 square feet? Another $21.50, so 43. So what are we doing? Do we need to divide, or are we getting bigger? Getting bigger. Cost multiplies, yeah? So we actually have to multiply the 6 times the 2150, because it's 2150 for every single square foot. 1 square foot is 2150. Another is another 2150, and another 2150. So we are multiplying now, and what does that give me? $129. Pretty good. Okay, do you have questions for me? Okay, ladies and gentlemen, you guys have a worksheet.